Hi, welcome back to my channel. Today, we discuss about a problem related to the triangle. Whenever you solve the problem related to the triangle, then mostly you use the sum of angles in the triangle or you use the exterior angle of a triangle. Okay, we are using these kind of the properties in a triangle. Beside that, we can use many properties, but for the moment, we are discussing about these properties. Here in this problem, we have to find the value of x and y. Okay, let's see how we can find these values. If you look closely in the figure, if you look into the x, how to find the x here? If you just look into the triangle ABC, you can see BCG is the exterior angle. And you know the concept well that exterior angle is always equal to the sum of non-adjacent interior angle. So if you take BCG as an exterior angle, then this will be equal to angle A plus angle B. Okay, B means ABC, right? How we can find the ABC? Because it's already given angle EBO is 90 degrees. So we can easily find the value of ABC. So let's find the value of the ABC at first. Here, angle ABC plus angle EBO. Look closely in the figure that is equal to 180 degrees. So what is the reason? It is a sum of linear adjacent angles. Now, from here, we can just keep the value of the EBO as 90 degree, and then we can find the value of ABC here, okay? So ABC is 180 degree minus 90 degree, angle ABC is 90 degree. You know why we found the value of the ABC, right? Now we can take angle BCG in triangle ABC as exterior angle. Look at here. Angle BCG is equal to angle A plus angle ABC, correct? So from here, what is the reason of this? It is exterior angle. It is exterior angle is equal to the sum of non-adjacent interior angles. Okay, so let's keep the value of the BCG. It is 145 degree. And what is the value of the A? That is X. And plus ABC is 90 degree. So what is the value of the X now? 145 degree minus 90 degree. So it gives you the value of the X as 55 degree. Okay, now we use the exterior angle in such a way, right? Now let's look at the value of Y. How can we find the value of the Y? If you look at the value of the Y, then we can see in the triangle ADE. In that triangle AD, this Y becomes an exterior. Y means the angle FED, right? So look into the triangle AD as FED as exterior angle, then we can take FED as an angle A plus angle ADE. Look at this. Angle FED is equal to angle A plus angle AD. Why? It is the exterior angle of a triangle, right? Which is equal to the sum of non-adjacent interior angles, isn't it? So let's keep the value of the FED, that is Y, obviously. What is the angle A? That is X, and angle AD is 110 degree. Okay, and we have already found the value of the X as 55 degree, so let's keep the value. Y is equal to 55 degree plus 110 degree, which gives you the value of the Y as 165 degree. Okay, in such a way, we can, by using the exterior angle concept, we can easily find the value of the X and Y. Okay, let's move to the next questions. Here, this is another question. In this question, let's see what is given here. In the given, QO bisects angle PQR and RO bisects angle PRQ. Before we move into the, like what to find, okay, let me just give you a quick concept of the bisect. Okay, what is the actually bisect means in maths? Normally in maths, the two words which is very important, okay? One is the bisect, another word is the divide. They are not the same. Divide means something which you just divide it, maybe equal or maybe not equal, but mostly you divide something into two parts only. But when I use the word bisect, bisect means exactly into two equal parts, remember, okay? For example, let me give you one very quick example here. Suppose I'm giving you this angle. Look at this angle. This is X, O, and Y. Okay, so I'm just giving you this angle here, X, O, Y. Now, let's imagine that there's a line segment OA which will bisect the whole angle XOY. I will call that, okay, XOY by OA bisects the whole angle XOY. What will happen when OA bisects the angle XOY? Then these two part of the angle will be equal. Do you know what are these angles? One is the XOA. Okay, this is the XOA. Another one is the YOA. These two angles will be equal. Okay. Now here we can just say that now in these terms, we can say the whole angle XOY. This is the whole angle. it is bisected into the two equal parts. So I can just say here, this is angle XOA, and then plus this is angle YOA. So you know that the whole angle XOY is bisected into two equal parts, that is XOA plus YOA. That is a whole part exam. So since these two parts of the angles are equal, then can we just replace this XOA by the angle YOA? Obviously, we can do that, right? So if I just replace XOA by YOA, then this YOA remains the same, okay? And then what will happen, you see? There are two equal angles here. You can see YOA. They are both the same angle, so we can just add them and we can get as twice of angle YOA. Just keep in your mind, okay? Or if I replace this angle YOA by XOA, then we can even say this whole angle XOY is equal to twice of angle what? That is XOA. So from this, what we conclude here is that the whole angle, if it is bisected, then we can express the whole angle in terms of twice of its parts, or the part angle is as equal to the half of its whole. So this is the concept that we try to understand, okay? So don't forget this concept. Now we're applying this concept in the given problem, okay? So for that, now listen, here, let's see what to find here first. We have to find the value of the O. Now clearly you can see that O is in the triangle QOR. Which means in order to find the O, then obviously we need the help of that what? OQR and ORQ. Unless we find the value of the OQR and the ORQ, we are not able to find out the value of the O, right? Now, since the angle P is also given 80 degree, that the big triangle is also there, okay? So we need to use the 80 degree also. Let's see how we can use it. Let's find a solution. The number one, since the angle PQR is bisected here, already I explained the concept of the bisecting, okay? So can I express this PQR in terms of its twice of the part of the angle? It means that can we express PQR as a twice OQR? Obviously, because it is bisected. We can just write the reason, QO bisects angle PQR. Maybe in your mind, you must have been thinking that, why I'm taking twice OQR? Can I take the twice PQO also? Obviously, that is also true. But here we are not taking twice angle PQO because angle PQO is not required here in order to find the value of the O. In order to find the value of the O, we need angle OQR. That's why we express PQR in terms of twice OQR, not twice PQO. I hope it's clear. Okay, let's go to the next one. PRQ is also bisected. Now, can you tell me what is that PRQ is equal to? Twice of which part? We can easily say it's a twice of ORQ. Got it? Now, if you look into the big triangle, angle P is given as 80 degrees. So can I use the sum of angles in a triangle? Obviously. Look at here. Angle P plus angle PQR plus angle PRQ. That is equal to 180 degree. Okay. Now, what is the value of the P? That is 80 degree. Okay. And that is 80 degree plus C. PQR is given as a twice OQR. So I replace it. And PRQ as a twice ORQ. I also replace this one. Okay. So let's get the value in this way. We just transpose the 80 degree to the right hand side. It is 180 degree minus 80 degree. From here, we can take the common 2 and the angle OQR plus angle ORQ will become 100. It's 100 degree, right? If we divide by 2, then we'll be getting OQR plus ORQ is equal to 50 degree. Okay. Now, as we got the value of the OQR and ORQ, does it help to find the angle O? Obviously. Now we can use the sum of angles in a triangle, in the small triangle, in order to find the value of the O. Now, what is the sum of angles? Angle O plus angle OQR plus angle ORQ is equal to 180 degree. Let's keep the value of the combined value of the OQR and ORQ as a 50 degree. We can keep it. So angle O plus 50 degree gives you 180 degree. So what is the angle O? 180 degree minus 50 degree. And what is angle O? That is 100. Okay, that's a 150 degree. I've written, sorry, that's mistake. It is 130 degree. Okay, you can write 130 degree. Okay, let's move to the next questions here. Now, look at this problem. It is again a triangle, but here, what is important? There's a paraparallelance is given. That is PQ is parallel to ST. So what is given here? It is PQ is parallel to ST. And it gives you a lot of ideas here. When the parallels are there, always what do you think? You think of the alternate angles, you will think of the corresponding angles, and you think of the co-interior angles, right? Let's see what we have to find here. We have to find the value of the P, Q, and R. Okay, and here, let's get the solution. Before we find the PQR, let's look closely in the figure. There's a different triangles you can see. You can use the exterior angle concept. You can use the sum of angles in a triangle. But I think closely, if you look here, there's a one value we can find easily, that is P. Look into the triangle SQR. P is the alone, which is unknown, right? So can I find the P, the value of the P by using the sum of angles in SQR? Obviously, I think we can find it. So number one, I'm using the sum of angles in a triangle. That's SQR. So that is SQR plus QSR plus angle R equals to 180 degree. So what is the reason? Sum of angles in a triangle. Let's keep the value. What is the value of the SQR? That is 44 degree. And what is the QSR? See, QSR is divided in two parts, that is P and P, right? So I can write P plus P in the bracket. And what is R? That is 40 degree. And that is equal to 180 degree. Got it? So let's calculate this one. Twice P plus 84 degree equals to 180 degree. And that will get 180 degree minus 84. And that's P. Okay, I've written the same. So twice P is 96 degree, which gives the value of the P. If we divide 96 by 2, we'll be getting as a 48 degree. Okay. Now here, the next value we can find, there's a pair of parallel lines given. So can you look closely into the figure? So here we can see here the angle Q and P, they are related. They're just alternate. Okay, see P and Q, they're parallel lines. In between the parallel lines as alternate in the Z form. So can I say that angle PQS is equal to angle QST? It is alternate angles. PQ is parallel to ST, right? So what is PQS? That is Q, and QST is P. We have already found the value of the P. So what is the value of the Q? That is 48 degree. Okay, I'm sure that now you can find the value of the R. So if you look into the big triangle, okay, PQR, we can use the sum of angles in a triangle. As well as if you look into the triangle PQS, you can use QST, QSR as exterior angle also. So it's up to you how you want to find it. But here I'm finding as using the sum of angles in a triangle. So in a big triangle PQR, I'm taking angle P plus angle PQR plus angle R equals 180 degree. That is sum of angles in a triangle. Got it? So let's keep the value. Angle R plus what is PQR? PQR is divided into two parts, Q plus 44 degrees. So I've just kept inside the bracket. And what is R? That is 40 degree. So that is equal to 180 degree. And let's keep the value of the Q also, that is 48 degrees. So I think we can just keep the value of the, okay, 48 degree plus 44 degree. Let's add it. Then R will become 180 degree minus 132 degree, which gives the value of the R as 48 degree. Okay, here is another problem. Okay, let's see what is given in this figure. In this figure, given is PQ is parallel to ST, right? Now what we have to find? We have to find the value of X, Y, and Z. Let's see the solution. First of all, you have a triangle and a pair of parallel lines there, okay? If you look into the triangle PRT, can we write something like this? SRP, look at the SRP, that is exterior angle, is equal to RPT plus angle T. You can see that SRP is exterior angle since TR is extended up to S, right? Now, the reason we can write like this, exterior angle is equal to the sum of non-adjacent interior angles. Now, let's keep the value of the SRP, that is 55 degree, and RPT is Y, and T is 36 degree, right? So let's calculate the value of the Y. We'll be getting 55 minus 36 gives you the 19 degree, okay? In this way, we can find the value of the Y. Now, let's look at the X. If you look into the X, this is in the alternative form. Can you see that? It's in between the pair of parallel lines. So we can just use like this. Angle T is equal to angle TPQ. Why? Because the alternate angles and PQ is parallel to ST. Okay, now let's keep the value of the T, and that is 36 degree, and TPQ is X here. So what is the value of the X? That is 36 degree. Now, let's think of the value of the Z. How can we find that? It is closely, you can, if you see that, it's we can use here the sum of angles in a triangle. Clearly it is seen, right? So in the triangle PQR, we can use the sum of angles in a triangle. So let's use it. In triangle PRQ, we can use PRQ plus RPQ plus angle Q equals to 180 degree, sum of angles in a triangle. So let's keep the value of all these angles. PRQ is 90 degree, and RPQ is divided into two parts, so X and Y. So I have written in the bracket, and then plus angle Q is Z here. So we have already found the value of the X and Y. So let's keep the value of the X and Y. That is 19 degree plus 36 degree and plus Z equals to 180 degree. Okay. From here, we can easily calculate the Z, and that is 180 minus 145 degree. That equals to Z equals to 35 degree. Okay. Let's move to the next question now. So this is a little bit different question. There is no values. And here, let's see what is given in this figure. In this figure, the given is that see AY bisects angle BAC and X is perpendicular to BC. Okay, you can clearly see in the figure. Now here, we have to prove here is the angle XAY equals to 1 by 2 angle B minus angle C. Here, nothing, we are not finding any values. We are just proving the XAY equals to half B minus C. Now for the solution here, first of all, what you need to think is that there are two things are given, which is very important. One is the AY bisects angle BAC, another X perpendicular to BC. Now the given is very important. We need to use them properly, okay? In the first case, we can just simply take the sum of angles in a triangle. See, angle B plus angle BAC plus angle C 180 degree. The reason is sum of angles in a triangle. Remember, always keep your eyes on to prove. We have to prove XAY is equal to half of angle B and angle C. That means that we need angle B and angle C, but we don't require BAC. So can I express angle BAC in terms of some other angles? Since angle BAC is bisected, remember the concept of bisector, already I explained, okay? Whenever the angle is bisected, we can express the angle in the parts of, it's a part, twice of its parts. So we can just do like this. Angle B plus twice angle BA, Y plus angle C equals to 180 degree. Because BAC is bisected, and we can express BAC in terms of twice BAY, isn't it? Now, here, we just, because AY bisects angle B, now we can just do like this. BAY also we can express, BAY also divide into two parts, so we can express in terms of angle BAX plus angle XAY, okay, divided. So here, let's multiply by 2, we'll be getting angle B plus twice angle BAX plus twice angle XAY plus angle C is equal to 180 degree. Got it? Because we need XAY. So keep your eyes on the angle XAY. Okay. Now, here we have got everything here. See, angle B is there, angle C is there, angle XAY is there. So what is not required is angle BAX. And look at closely in the figure. Angle BAX is in the right angle triangle, BAX, right? So we can express angle BAX in terms of angle B as a complementary angle. So can I do like this? Angle B plus BAX means the 90 degree minus angle B, because it's a complementary angle, isn't it? So I can give the region sum of complementary angles, right? And the rest of the angles are as the same, okay? Now let's multiply by 2, we'll be getting angle B plus 180 degree minus twice angle B plus twice angle XAY plus angle C equals to 180 degree. From here, we can cancel 180 degree and 180 degree, okay? And after canceling, then we'll be getting something like this. Now we can subtract from the twice angle B, so we'll be getting minus angle B plus twice angle XAY plus angle C is equal to 0. From here, we can get twice angle XAY, we transpose angle B and C to the right hand side, that will become angle B minus angle C. Now XAY will become now 1 by 2 angle B minus angle C.